And I'll be speaking about the T5 model, which was trained for the Polish language. If you're familiar with the T5 model, that's good. If you're not, I'll be very quick about it. So one part of the presentation is that we want to show you what we have. So the plT5 model, so the Polish model for the T5. And also we try to evaluate the models available for the Polish language on some various text-to-text tasks. And this will be the second part of the presentation. So the loose plan is like over here. There will be some small recap on pre-trained text-to-text models. So the T5 BART model and the GPT-2 that are available for Polish. Then I will show you how do they perform on Clay benchmark. Clay benchmark is like a standard benchmark for Polish models, similar to GLUE. Then I will show you how do they perform on machine translation, Polish-English, the knowledge Q&A task, and summarization task. And also at the end, I will try to show you how we use the T5 model in Allegro right now. This is a POC stage, but I hope something interesting will come out from this. So a very quick recap on generative models. The T5 model, which is the encoder-decoder model, based on transformer, is trained with a denoising objective. So you just mask some parts of the input, like over here. For inviting and last is marked with special tokens, here the X and Y. And what you are trying to do, you're trying to feed this kind of corrupted input into the encoder, and you are trying to predict by the decoder this kind of changed input when you just replace, when you just take the things that you replace with X and Y, and you're trying to predict this kind of spans of texts. So this is a T5 model. T5 model can be like used for any kind of text-to-text task. Text-to-text task is when you formulate everything with text. For example, if you want to translate something from English to German, you just use a special prefix. This is the translate English to German, and this is the sentence you want to translate from English to German, and you feed this into the encoder, and you're generating the answer, which is over here. And every task can be formulated as a text-to-text task. Even the classification tasks can also be formulated as text-to-text. You just use a special prefix. Let's say maybe not the summarization, but if you have some classification like is this part of text of positive sentiment, you fit that into the T5 model, and you generate yes or no, positive or negative, or something else. And this is also part of the fine-tuning process, that you want to somehow get those things that you generate right, because the model is sensitive to what you generate. For the binary classification, you can have 0, 1 to generate. You can have yes, no. You can have something else, A, B. And this matters a lot. So this is the T5 model. We trained this model for Polish language. The procedure was very simple. We just initialized from the multilingual T5 model, and we trained this for like 50,000 steps on the TPU from this publicly available repo. And we used some dataset mixture of Wikipedia, Wolne Lektury, NKJP, Open Subtitles, and CCNet. And you can also get this model from Hugging Face. This is one of the remarks that we only tested models that are available from Hugging Face. And I will get to that when we are at the point of GPT-2. The second model that we tried to evaluate with respect to our plT5 model was BART model. BART model is very similar to T5, except that we only corrupt the input. Which is then fed into the encoder, and what we do in the decoder, we just reconstruct the whole input that we corrupted. So it's very similar, but there is of course a strong difference between them, because I can see in the BART model we feed everything without the corruption into the decoder, but in the T5 model we just reconstruct the things that we hide from the input. And this is a very big distinction, and as you will see when we get to the summarization part, that the BART model has a very strong bias. Okay, and Polish BART is also available from Hugging Face. You can get it. It's trained from scratch, as far as I know, for 125 steps, 1,000 steps. All the models that we have here have vocabulary size of 50,000 tokens, and dataset was Common Crawl plus some other sources, so I don't know exactly which one. And of course, the checkpoint is also available, and you can use it in your code base from transformers. And the last one is GPT-2. It is also available for Polish language, and this is just a decoder model. So keep that in mind, that the previous models were encoder and decoder. So we have like two transformers there. And this model is just a decoder, but it's, I think, the most famous one due to the GPT-3, which was very popular in use. What you do, you just train the language model, so you want to reconstruct the input. And this is the only thing that you do here. But this was, I think, the first model which was used in a zero-shot setting. So when you have the language model, you can actually feed something like in a T5. So let's say that you can feed this kind of input, translate English to German, that is good, into this model, and you can keep generating the answer in a zero-shot fashion, so without fine-tuning. And I think this was the first model that actually did this kind of text-to-text evaluation or the prediction. And we have it for Polish language. We actually use the Papuga GPT-2 because there is a second model which is not available yet from transformers. It's available from Fersec, but we didn't use it because it requires some change of our code base. And similarly, it has also 50,000 tokens in the vocabulary. Dataset was Oscar corpus, and you can get the checkpoints, which is the base and large model from transformers. And I think it was also trained from scratch. So two things, BART and GPT-2 were trained from scratch. Our model was trained from the checkpoint of multilingual T5 model. So that is a clear distinction here. Okay, for someone who is interested in number of parameters, here we have it. Of course, the large models have the most parameters here. But what is actually interesting here is that the BART model here, which is the encoder and decoder, so it should have more parameters than the decoder-only models, is actually comparable to the size of a Papuga GPT-2. So even though it's decoder-encoder, it is the size of a simple decoder. It is also smaller, much smaller, twice smaller than our base plT5 model. And this is very interesting in terms of the performance as it gets. We didn't have time to evaluate the largest GPT-2 model, unfortunately, but it's very interesting because it is of the size. So the simple decoder here is of the size of an encoder-decoder of our largest model, of our largest plT5 model. Okay, vocabulary size, as I said, for the multilingual model, you have like 250,000 tokens, so it's a big vocabulary. But for these Polish models, we only have 50,000 tokens, so we can reduce significantly the number of tokens, and this speeds up the prediction, and of course, it doesn't take so much memory for training. Okay, so the first task I want to show you is the clay benchmark. Keep in mind that clay benchmark is either a classification task or a regression task. So you can have standard classification models or regression models, and you can have some results over there. But what we evaluate here is a clay benchmark on a text-to-text task. So what we do, we just feed the input of the task into the encoder or to the GPT-2 or the decoder model, and we generate the answer. We don't just map it into a label, some fixed labels, but we generate the answer. So, so what you can see here for this plT5, Polish BART, Papuga GPT-2, MT5, these are the scores for text-to-text tasks. These are not the scores for this standard classification procedure, whereas the Herbert here, these are the scores for the standard task, not the text-to-text tasks. So when we compare, for example, the plT5 and Herbert, we should keep that in mind that this was performed for a text-to-text task, and this was performed for a standard classification or regression task. And what we see here is that our plT5, or all these models like text-to-text models here, have smaller performance or lower performance than the Herbert. So they are still below the standard classification or the regression procedure. But as we can see, our base model, or even the largest model, has the best performance among other models. What is interesting here is that the BART model over here, which was very small, which was twice smaller than the Polish base model, is not that bad. It's actually very good. At some tasks, he even surpasses the scores of our plT5 model, and it's even better than the Herbert. So this small model is actually performing very good. And this is the first good observation. Of course, we have the plT5 model is performing, of course, on average fantastically, and not that good as Herbert, but the Polish BART, which is smaller, is also performing very good. And this is the message from this slide. The GPT-2 here is not that fantastic, I would say. It struggles on a CBD, which is the cyberbullying detection task. But an overall, like BART and plT5 are the best choice on a clay benchmark. I want to say one thing about the BART here is that you may see at some point the performance of BART on this clay benchmark website, but this probably won't be the performance of BART on a text-to-text task, but on a standard classification task, because BART can also be used like in a standard classification task. So you should also keep that in mind. It may be even better than what you see here, but it may not be the text-to-text task. Second task is machine translation. Here's some data sets that we used. It's not interesting right now. This is just all data sets that you can get for English to Polish translation. So we collected the training data sets. We evaluated the results on a VMT20 development set, which has 2,000 examples. But to the results, still our model, which is the plT5, and over there, the base and the large are performing the best on English to Polish translation, and also maybe not that good for the Polish to English. Sorry, from English to Polish, our model large is the best, but maybe not from Polish to English, because then the multilingual T5 model is best, but these T5 architectures actually are performing the best in these tasks. So what we did here, this is the BLEO score, of course, for the translation. What we did here, we just trained the model, which is the bidirectional, what we say. We just feed both the English to Polish to English translations and English to Polish translations into the model. So we trained both languages at the same time with some control tokens. Because you can get much better results if you train separate models for each translation language. So you don't train for both languages, but separately for English to Polish or Polish to English. And as we can see, the BART is not performing that well as our plT5 model. So the conclusion is that indeed we did some improvement here. And this VMT20 and MT5 plT5 vocabulary is just what kind of vocabulary we use, because in the translation you can use the vocabulary of a model that we use all the time, but you can also like shrink it into some task-specific vocabulary, and this task-specific vocabulary, which has 32,000 tokens, is exactly the VMT20. But this is not the subject of this talk. So the plT5 model was the best here. And next task is knowledge Q&A. These are the standard data sets that we use. The knowledge Q&A is like, I'm asking you the question, like in 1 z 10, and you have to generate the answer. Yes, no, some person or whatever. So this is the knowledge task. You don't have a passage like from Wikipedia. You just have to figure out what is the answer from your memory or whatever. And this is what we get in terms of accuracy. on these two datasets that we had from training, and we evaluated on PO level. The performance is really poor, like at most 14%. So all these models struggles with generating correct answers. But if we take the plT5 model, it has the best performance, like 12% compared to BART, which is 11%. But still, if you take this plT5 model and then still fine-tune it only on Wikipedia, so not on all these data sets that we have previously, but just you take Wikipedia and still use the denoising objective to fine-tune it further, you get a little bit better score. And this is a message from this task, but in overall, they struggle heavily on this knowledge Q&A task. But if you include the passages, then I think the performance jumps like to 50%. So the passages are really very good. Summarization, I still don't have much time. Summarization, we took two corpuses, Allegro articles. These are the articles written on Allegro websites. And the second one, which is Polish summary corpus, which is split into the extractive summaries and abstractive summaries. The Allegro articles are abstractive summaries. And we have two different domains, the e-commerce domains and news domain. And this is just a slide showing you what kind of summary you can actually perform, because each article is composed of title, lead, and a body. What you can do, you can take the body and the lead and generate the title, if you consider this as a translation. Or what you can do, you can take, for example, lead or the body itself and generate the lead. This is a different kind of task. I don't have much time to actually show you what's the difference, but the interesting thing about this summarization task is that the Polish BART is actually performing best. It even surpasses the baseline, whereas the other models do not even surpass the baseline, which is like copying a few sentences from the beginning. What is the reason for that is that the BART has a copy bias. If you look at the BART model, the procedure, how we train it, is like we just corrupt the input and we reconstruct the same input. So if you do not corrupt the input, you will always copy the input. So this is the copy bias, as we call it. So when you do nothing to the input, you will have a tendency to copy the same source into the input. And this is actually a very strong bias for example, news summarization, because most of the summary is at the beginning. So if you copy the news, you're in a privileged situation. Whereas if you look at the T5 model, if you do not corrupt anything, you will have nothing here. So it doesn't have this copy bias as BART does. That's why it's more difficult to fine-tune on the summarization, whereas BART has a very nice bias and is privileged on this task. And lastly, our use case. So so you can take the T5 model, which is the encoder and decoder, and take some historical data of chat conversations on Allegro. You can write to Allegro help, and there will be some consultant writing your answer. You can take those chats, take those threads, and train what we call the prefix language model. So you fit some context, which is a few messages, and then you generate or try to reconstruct during a training the answer that the consultant wrote, for example. And you can use it as a part of a chatbot, a generative chatbot. And this is actually, right now, this is a POC project. We are in a stage of a POC, so a proof of concept, that we want to deploy the chatbot for a Slack channel, which is the IT support. And one of the components of this chatbot is exactly this generative component, which generates the answer. But of course, this is not the only thing, because as we know, the generations can be uncontrolled. So what we have in a chatbot also is a retrieval model. So we can retrieve some previous historical responses. But if we are bad at the retrieval, we can still fall back on the generative part. So try to generate the answer. And this is at the POC stage, and we hope it will work very well and maybe turned into a real chatbot on Allegro website. Who knows? So in a summary, so we trained the T5 model for Polish language. We also tried to benchmark T5, BART, and GPT-2 on various text-to-text tasks, Clay, summarization, machine translation, and knowledge Q&A. So in general, the larger the model, the better the results, as you may expect. Text-to-text tasks are still below BERT performance, but I want to say here that we didn't perform any fine-tuning for the things that we generate, so for the labels. But this is also very important, to choose the proper labels. A, B, 1, 0, yes, no, it matters. plT5 performs best in Polish to English machine translation. Knowledge QA is very difficult for all models, and BART model is performing very well, especially on news summarization due to copy bias. So that's it. Thank you very much. Do we have time for questions or no?
Yes, yes.
Any questions?
I have a question.
Yes.
Have you written any article about this plT5?
Yes. So the question is, do we write an article about the plT5 model? Yes, we do. And it is in a, maybe it will be released at some point, but it is over here. So all these tables were from this article that we write right now. So we just performed like a hackathon for 1 week to evaluate all the models. We burned a lot of money for that because each model was trained with different batch size, with different learning rate, and also with different seeds. So this was a lot of money, especially for large models. And yes, we do have an article, and we are writing it right now. We are in a stage like we are finished, we are done with this. But as you have seen, we didn't perform all the things that can be performed. For example, tuning the prompts, tuning the answers that we generate. Maybe we have problems with GPT-2, and we have also problems with large models on summarization. I didn't dwell into that, but the scores for the large models were for summarization tasks were really bad, even worse than the base models. We just ran into some instability, and we didn't investigate this further. So there is room for improvement and room for testing, also for different data sets, if you wanna try.
Thanks. I have a question. So thank you for a great talk. If I understand correctly, you use slightly different data sets for different language models that you train on Polish language. And first question is, what is the reason for that? And second, do you think that this can affect the metrics on Clay benchmark that you train on slightly different data sets? Thank you.
Okay, so your question is that different models use different data sets for pre-training? Yes. I don't know, personally. If it matters, maybe, but the data sets are not quite different. I mean, I'm not sure. I'm not sure because this is also the case for Herbert or the Roberta that we have for Polish. Because, for example, the Allegro used NKJP, which was not available for other models, which is a very clean data set. Personally, I don't know if it affects performance significantly if you exclude some data set, or maybe some of the data sets are dear tier. I don't know. Yes.
If I understand correctly, you use the multilingual T5 model as a checkpoint, and you restart the training from this point, and you change the vocabulary as well. Yes, so you have new embeddings for the vocabulary. Did you make any shenanigans to make the training robust, or did you make an evaluation study if this restart from the checkpoint actually helped the training?
Yeah, that is a very good question. The question is about the vocabulary, because indeed we start from the T5 checkpoint. The T5 checkpoint has a vocabulary size of 250,000 tokens, but our vocabulary has 50,000 tokens. And what you can do here is if the tokens of our vocabulary are in the tokens of the multilingual vocabulary, we just copy the embeddings. to our model. But if they are not, so for example, we have in a multilingual some token, which is not present in our vocabulary. So what we do, we tokenize this token, and we average the embeddings and put into our model. That's why this is the procedure of shrinking the embedding layer. But you may ask a question, what would happen if I just took a new embedding layer, which was randomly initialized? No one has tested that, even in a Herbert model, which also used this procedure that we just shrink the embedding layer from some multilingual model and then keep fine-tuning further. We actually didn't perform an experiment where we just could take a random embedding layer and just keep fine-tuning. What would happen? And also the question is if it actually helps initializing from T5 checkpoint. We don't know. We don't have answer for that because it would require some additional training. Maybe someone with more money would do that. I don't know.